So today we're going to do a video on the 10 steps to create a new morph, which a lot of people aren't going to think is possible, but I personally believe it is 100% possible. And I need to put a lens hood on this because I am seeing a reflection of my light in the lens. So 1 second. The lens hood I thought fit this does not fit this, so I guess we're just going to roll with it. Okay, so it does sound ridiculous what I'm saying is 10 steps to make a new morph, but it's actually possible. And the worst case scenario in doing this is you end up with a bunch of polygenically stacked awesome traits that give your animals their own significant specific look, and I'll get into that later. Okay, so if you want to make a new morph, or at least attempt to make a new morph, this is the steps you got to take. There's 10 of them. Okay, step 1, find a retic that looks unique and different in some way. Whether it's color, whether it's back pattern, whether it's side pattern, whatever it is. Like it could be color, pattern, structure, whatever. Just find something that looks unique. All right? That's step 1. So chances are you're producing something that looks just completely, not completely, but noticeably different in some way. So find that original animal that has something unique about it. Step 2 is to find preferably a second animal that's also sharing some of those traits. A lot of times you'll find this in the same clutch or in stuff that's 50% related. Say you bred X locality to this, and then that same snake, say you had a male and you bred it to this other animal, and in each clutch you got something that was unique and similar. Try to get a pair. If you can get a pair of animals that have similar unique traits, that's going to put you miles ahead. So that's step 2. Sometimes you can't find a pair that has these traits. A lot of times you actually can. You just have to really look for it. Typically in your own collection you'll find it. The third step is put together a small group of locality animals that will amplify that look. And what I mean by that is if you've got something that's kind of leaning towards a red color that you want to work with, get a Solaire. If you got something that's kind of really dark and you're trying to push some dark pigment, get a Halma. If you got something that's really silver, you want to try to do some sort of high silver potential project, new morph, whatever, you could get a Karampa or a high silver Kalatoa. So try to figure out a way to find the right locality and the right example of that locality that's similar to this unique retic that you have that you want to try to develop into a new morph. That's going to help significantly because there should be some traits that either line up or they are able to really amplify the look you're going for. So that's step 3. Step 4 is you want to start doing breedings to isolate that trait. And I don't necessarily mean line breeding at this point. This is the point where you want to start trying to get that trait into like those localities, to start trying to really isolate it, and you don't want to water it down. Like if you're going for thick black, right? You're going for thick black on something, you got something that popped out, it's pretty thick black or whatever. Don't breed it to a Coyote. You know what I'm saying? Like now you're moving backwards. Now you're fighting against the trait you're trying to basically exaggerate. So make sure like I said, you're getting the right localities that amplify it. And then step 4 is to actually do the breeding to try to really start to add to that trait. Because, they might be compatible, they might not, but they'll actually start to stack up in a way where they kind of compound on each other and you get even more of the look you're looking for. Okay, step 5 is more of a step to things to avoid. Okay, if you have a trait that will go good with a morph, that's fine. If you can find a morph that has some of these traits already, the visual morph version, that's great. But if you're trying to create thick black, thick whatever, high color, whatever, don't run it into some triple or quadruple morph combo, because there's so many genes, especially in the mainlands, that are essentially just watered down, mediocre color, mediocre pattern structure, mediocre thickness of black. The last thing you want to do is start adding in mediocre polygenic traits when you're trying to enhance a specific look, because all that mediocre genetics that you see in a lot of the mainland morph combos, they're just what's left. Basically, all the other cool unique shit basically got bred out. So now you're just left with this average color, average pattern structure, average thickness of black. So that's step 5, is really avoid moving backwards. So if you do want to get whatever you're trying to create into the morph space, use basically a single gene animal to do it, that hopefully has some traits that are going to, really boost the look of whatever you're trying to essentially turn into a new morph. Step 6 is, now that you've done some breedings, you should have like 2, maybe 3 breedings by step 6. I know we're only at step 6, and this is fucking years worth of work. But step 6 is, now that you've done some breedings, it's time to really go through the offspring and really start to analyze what you've produced and see what's being replicated from this new trait you're working with, and start picking out those animals. So you have your original group of animals that has whatever trait that you'd like to try to turn into a morph. You've got it bred into the localities to basically exacerbate that look, and you've potentially added a single morph to it to also help exacerbate the look. And chances are, if you are trying to make a new morph, first the goal is to create a new morph, and then the second goal is to figure out what morphs it's going to go well with. So that needs to be in the back of your mind too. Like, okay, so there's 2 goals here, which create the new morph, figure out which morphs it's going to really work well with. So you should have already figured out, with that single gene morph you're using, you should already have a good idea of what direction you want to potentially take a new morph. So that's step 6, is you're picking out the snakes that have actually shown the traits you're working with to be reproducible, because it's expressed in the phenotype. So now that you've really got some unique looking snakes, and this would be basically round 2 or 3 of this reproduction of this look, now it's time to take it back into whatever specific pattern or color spectrum you're trying to match it up with. So say you're trying to go for side banding, right? You're trying to create like a heavily side banded animal to the point it's basically a morph, or becomes a morph. So you can do that a couple different ways. You could really start trying to match that up with a morph that does that, or a locality that does that. So you're folding it back into the locality at this point to really try to line up all the traits that create this side banding look you like. And if, say, you want side banding, so you got something like Platinum or Sunfire that also helps create that as well. So you could also be folding it back into that. So you could be taking it back to X locality / Sunfire, X locality / Platy. So that's something to think about there for step 7 is, okay, so now I don't want to say you're backtracking, but you're basically going to go back and double dip on some locality traits to try to lock in these secondary traits that have proven themselves to be reproducible. So you want to just keep, basically on a chromosome, you're trying to take up as much space as possible with these traits, okay? And that's why you're going to go back and double dip into the localities again. All right, so now that you've done this breeding, so this is like 3 or 4, this is when you're really going to have to start line breeding. So you produce a clutch that has these traits that you like, and this is like the 4th time you've proven that you can produce these. Now's when you really start line breeding. And a lot of times 99% of the time, I recommend not line breeding. But if you're going to make a new morph, that's how they're made in the wild, just natural inbreeding, other genes gets pushed out, these polygenic traits and some other traits get locked in, and boom, you get a new morph. So this is when you start line breeding. So now you're to the point that you're breeding siblings, or you're breeding an offspring back to either the male or the female, and you're really going to try to lock it in at this point. So you know that you're definitely reproducing this at this point. Step 9 is you've done this line breeding, and now you have a clutch, and now it's really time to isolate what is actually reproducible. Okay, so are you seeing a reproduction of 100% in the clutch? Are you seeing a reproduction of 25% in the clutch? Are you seeing a reproduction of 50% of the clutch? When you breed these animals together that have a very similar look for whatever trait you're trying to just have take up all the space on the chromosome, on the chromosome level, to be locked in there. So this is when you're going to have to start doing some math and start figuring out, okay, what is the rate of reproduction of this trait? So, and that's step 9, because that's what comes after the line breeding. You get the clutch, and you're really starting to figure out the math. Is it working? Like, does this, we'll call it trait X. So does trait X coming from the male and female, does that produce 25% trait X? Does it produce 50% trait X? Does it produce the whole clutch looks like trait X? Or are you getting 50% trait X, 25% basically look like normals, don't have the trait, and then maybe another 25% have an even more exaggerated expression of this trait, almost like a super form? That's when you got to figure that out. So you do that breeding, and you figure out what you get. And then you're to the last step. You're at step 10. Step 10 is to take that trait, whether it looks to be an exaggerated super form, just a regular form, and you have to breed it to something that doesn't look like it. Because now, like, this is the last breeding you're going to have to do, because this is going to be the one, unless it's simple recessive, you might have to do another one, breed the offspring back together. This is going to be the one that proves it one way or the another. Because if it's a morph and you breed it to something that doesn't look like it, say if it's a codom or incomplete dominance, right? If you created this incomplete dominance through all these breedings, and then you breed it to just a normal retic that doesn't have any of this incomplete dominant trait, you should get from that clutch a half a clutch of that trait. And at that point, then you actually have proved it out as essentially a new morph. Worst case scenario, you prove it out as a polygenic trait that's reliably reproducible, which is basically still a morph, and you could actually argue there if it is or if it isn't. Like, if it's strictly just polygenic and you breed it to a normal that doesn't have it, and say half of the collection gets it, okay, so then it was at least able to pass the half, right? But if those polygenic, if it is only polygenic, and you keep breeding offspring back, and you notice that each time you're getting a little less and a little less of this look, that's when you'll know it's actually not a morph. Because, like, if you take Golden Child, you're never going to just be able to breed out the Golden Child. So it is a locked in morph. So that's kind of the step you're on. You are going to have to do some breedings there to figure out if it's an actual morph, or if it's actually just a polygenic trait. But worst case scenario, you end up with this polygenic trait that's decently reliable in reproduction. Okay, so worst case scenario, you do all this selective breeding, and the whole way with all these breedings you're doing, each time you're creating a look of your own, you're creating genetic diversity, and you're doing selective breeding. So all these breedings are all adding up in hopes to a new morph. But in worst case scenario, you're just creating basically your own line, your own distinctive look of reproducible polygenic traits. And that's not who does that hurt? Nobody. That's still a win. So worst case scenario, You're producing better looking snakes, genetically stronger snakes, with the exception of a couple of line breeding that you had to do, and you're creating your own look. So, and you're going to be using localities the whole time and throwing in a morph. So you're improving, you're diversifying genetics. You're improving an already existing morph while potentially creating a new morph. In worst case scenario, you don't. You just create all these awesome looking reproducible traits that can be bred out, but they can also be bred back in. So that gives you an opportunity to keep pushing your stuff forward. So this is the 10-step plan to how to create a new morph. And the failure of creating a new morph is you just get a bunch of awesome snakes that are genetically awesome. The phenotype is awesome. And as long as you keep these polygenic traits in line with each other, you can create very unique looking stuff, which means the price is higher on all your stuff because aesthetically speaking, it's just significantly better. So worst case scenario, you don't create a new morph, but you create a whole bunch of awesome snakes that sell for more money than other people's. So I do recommend, if you're in this long term, to start trying to create new morphs, because even if you fail at it, all it's going to do is cause you to have very unique, nice animals that look amazing, genetically stronger, aesthetically better than other people's. Well, you're basically just creating your own brand in the form of a phenotype. So that's worst case scenario, is everything you make is better than pretty much everybody else's. That's worst case scenario. Best case scenario, you get a new morph. So that's what I recommend. I really like this lens, by the way. This is the Auto Recanon 17 millimeter f4. A lot of people wouldn't like it because it's a slow lens, only an f4, but it is quite old. It is, I think, I don't know, 40, 50 years old. Made in Japan. It's awesome. I think it's like brand new. The only thing this lens has wrong with it, has a little tiny like speck of a scratch on the front element, which the front element of this type of lens doesn't really do shit. So the front element on this essentially doesn't even matter. But that's it, man. This lens like 50 years old. It's like literally looks brand new. So I mean, I'm going to start doing more stuff on camera lenses. I'm going to start doing more stuff on using cameras for video and photos. I think people are missing out on an excellent opportunity to start adding photography and cinematography into their reptile keeping. I think it adds a nice dimension to this, that it's like a piece, it's like adding a new dimension to your current hobby to make it more exciting. So but yeah, it's a great lens. Good luck on finding it. I've had it, and I've never seen another one. It's also under another name. It starts with an S. I can't remember what it is. It's not Secor. It's I forget. But anyways, not that you give a shit about this lens, but I really like how it's rendering. Good skin tones, good contrast, good everything. So yeah, not bad for a lens from the 70s or 60s. I think it was 70s. That's it for today. Start making new morphs. Fuck all these old breeders. They're retarded.